In this video, we are going to learn how to do mole-mole ratio problems. And what that really means is that we are going to figure out how many moles of each individual reactant or product we're going to need in the proper ratio. It's basically like if you were to use a cooking recipe, right? This pretty much says, one nitrogen plus 3 hydrogen molecules make 2 NH3 molecules. Well, if I have 2 nitrogen, or 2 N2s, then I would need 6 H2s. And it's essentially, that's what we're doing. But unfortunately, it's not always whole numbers. So the way we do it is you pretty much use the balanced chemical equation. So in this, for this setup, I pre-balance these equations. You have to know how to balance chemical equations. If you can't balance it, then you have to go back and watch those videos, because if it's not balanced properly, everything we're going to do today is wrong. So the first question says, how many moles of NH3 will 0.6 moles of nitrogen produce? So when they say nitrogen, they're talking about N2. You're expected to know that because nitrogen is a natural diatomic. It's part of Brinkelhoff. It's part of the 7 elements on the whole periodic table that are naturally diatomic, so you're going to have to be aware of that. Now, what I'm going to do is I'm going to set up a ratio. Now, normally, if it was just one problem, I would just put my fraction right here and go 0.6 over 1 like this. I'm going to write it down here because I'm going to be reusing the chemical formula for problems 2 and 3 as well. So the first thing I do is I go 0.6 over 1, and they want to know how much NH3. Well, I would put an X over here, so X over 2 NH3. So then I'm going to cross multiply, solve for X, and I'm going to get 1.2 moles of N2. It's that simple. Now, obviously, we're going to make it more complicated because in real life, you can't measure moles. You can only measure grams on a scale, and then you use a mole formula to convert them to moles. So we're going to add that step in, but not today and not on these problems. So number 2, how many moles of H2 will react completely with 6.5 moles of N2? So I have 6.5 of the N2, so I would put 6.5 over 1. But always write the chemical equations in. The number one mistake students make is they don't write this in, and then they don't give me the right units. Or they'll plug them into the wrong spots. And they want to know how many moles of H2. And so I would go X over 3H2. Now I'm going to solve for X here, and I believe I get 19.5 There we go. Just double checking. 19.5 times 3. Next one. How many liters of NH3 will 1.5 liters of nitrogen produce? So I've got, now, here's the trick, okay? Since you can, so the long way, well, actually, I'm going to do the first one the long way, and then I'll show you how to fix that. This is really a 3-step problem. So we don't have, these coefficient numbers are moles. The best way to think of them is moles, and this is liters. So I should know this ratio and know how to use it. So this is going to convert my moles to liters directly. So now I'm going to cross multiply and solve for X. And I'm going to get 0.67 moles of N2, because they said nitrogen. Then I'm going to do a mole ratio where I do 0.67 over N2, and I want NH3, which is going to be X over 2 NH3, which is going to give me 1.3 moles of NH3. So here's my first step. Here's my second step. And then here's my third step. They wanted to know liters, unfortunately. I have moles. So now I use the ratio again to convert my mole number back to liters. There's my final answer. Now, I'm going to show you something a little bit easier, all right? Because think about this. Look at what we did in step 1 and look at what we did in step 3, all right? In step 1, we effectively divided by 22.4, and in step 3, we multiplied by 22.4. So I want you to think of a number, any number, multiply it by 10. Now divide it by 10. You're thinking of the same number, because that's how math works. So since we did step 1 and 3 effectively cancel each other out, watch what we can do. So instead of doing this, here's what I'm going to do. I'm going to take my 15 liters. I'll try to squeeze it in right over here. I'll use a different color to make it stand out. I can do this. 15 liters over 1 and 2 equals X liters over 2 NH3, cross multiply, and you get which is your answer. So, kind of separate this out. One thing to keep in mind is when you're using liters, they can be also used just like their moles. And the reason is for any gas, 1 mole is 22.4 liters. So you're either gonna multiply and then divide by 22.4 or the reverse. It doesn't make a difference what they give you to start with, but that's gonna cancel each other out. So you can get away with doing problem 3 in just one step. Here's the thing to remember. That will only work if you're dealing with liters for gases. If you're not dealing with liters, like if they gave you grams, all bets are off. We're not going to do that one yet, but I'll show you how to do that next. Next problem. When you balance it, it's 432. So then they say, the first question says, how many moles of aluminum are needed to form 3.7 moles of Al2O3? So I'd go to the equation and I'd put a 3.7 over this. I just go 3.7 over 2. But we're going to write the formula in. And then I want X over aluminum, which is just this. Cross multiply. And you end up getting 7.4 moles of aluminum. And that's it. Next one. How many moles of oxygen will react with 15 moles of aluminum? So 15 over this equals X over the oxygen number. So I would just put a slash and then X over 3. Cross multiply, solve for X. All right. And for the last one, it's another liter problem. I'm not going to do it in 3 steps. I'm going to do it in 1 step only just to show you how it works. And then that's it. So 10 liters of Al2O3, so it would be 10 over 2 equals, what do we want? Oxygen, so X over 3. So now cross multiply, divide out, and I get 15 liters of problem solved. If you wanted to do all 3 steps, you're welcome to it. You'll get a number that's 15 or very, very close depending on rounding. It could be a little above or a little below if you round it up or down a lot from the answer. And that's how we do mole-mole ratio problems. I went through these pretty quick because we're going to use this as the basis to do mole-mass and mole-mole or mass-mass problems, which require a lot more work. And this is kind of like step 1 of those problems.